Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class, we have almost completed all the theories regarding the chapter Deflection of Light. Today, we will be solving some numerical problems based on the theories of this chapter. Okay, so this I am taking these numerical problems from the Conscience Series book, class 9. Okay, some numerical problems will be from the examples and some will be from the exercise. And if you want any specific numerical problem to be solved, then you can mention it in the comment section. We will definitely solve those numerical problems separately. Okay, so for your convenience, I am just mentioning the questions so that it is easier for you to understand the solutions. Okay, so let us take one question. This is from the example. Okay, the question says something like this, that so this is question number 1. So it is saying that when an object is placed at a distance of 40 centimeter. Okay, so I am writing the question. When an object, I hope it is visible. Okay, now it is visible. Yeah, so it is saying that when an object is placed at a distance of at a distance of 40 centimeter from a concave mirror. So the mirror has been mentioned as to be concave. Okay, then it is saying that the size of image is 1/4 that of the object, 1/4 that of the object. Okay, now first question, calculate. What we have to calculate first is that calculate the distance of the image from mirror. That means the image distance of image from mirror. This is the first question. And the second part says the focal length of the mirror. So the focal length. So this is the question. Okay, fine. So as I have also previously told, that while solving a numerical problem in physics, please first of all note down what are the given things and what has been asked to find out or to calculate. So in this question also we will first of all see what are the given things. Now when the object is placed at a distance of 40 centimeter from concave mirror. Okay, before we solve the numerical problems, it is very important that you have understood the sign conventions properly regarding the mirror, and we have discussed in the previous class, and I think in one other class also, about the sign conventions in details. If you have not seen the sign convention before seeing this class, please do watch the previous videos. You will be able to understand where we are taking minus sign and where we are taking plus sign. Okay, so let us come to the solution. Okay, so what are the things given? It is given that the object is placed at a distance of 40 cm. So basically it is given the object distance. Object distance is generally denoted by the letter U, is equals to 40 cm, and as you know, object distance is always negative in nature, be it concave or convex mirror. Then it says the size of the image is 1/4 the size of the object. Okay, so we have to consider here, let size of object. Now what is the size of object denoted by? It is denoted by the letter O. So let us consider to be x. Then size of image will be how much? It will be size of image is denoted by the letter I. It is 1/4 of the size of the object. So it's 1/4 x, isn't it? It's 1/4 x. Now what is has been asked? It has been asked to find out the distance of the image from the mirror. Distance of the image from the mirror means we have to find out the image distance. Okay, so I am just erasing of the question. I hope you have noted down the question. If not, please pause the video and note down the question and then observe the solution. Okay, so when you have to find out the image distance, so how image distance, object distance, image size and object size are related? Now there is a formula of magnification. There is a formula of magnification. So magnification has a formula like this. Magnification of the mirror, it is denoted by the letter M. It is basically nothing but the image height by object height, and that is also equal to the ratio of the negative of the ratio of the image distance by object distance. Okay, so basically we will be just utilizing this part to find out the image distance. Okay, so how image basically image distance, so we have to find out this V. Okay, so let us see how we can do this. So therefore we can write, therefore minus V by U is equal to I by O. Now minus, let it be V, the image distance, let image distance be V. Okay, so we are just continuing the solution from this to there. So this is the first part, let's mark it out, otherwise it will be confusion. Then after this, from here we are continuing to this part. Okay, so minus V by U. Now U is minus 40, so let us take as minus 40. I is basically, I is how much? It is X. So no, it is 1/4 of X. Okay, now you have to consider, here it has been said that the concave mirror, okay, the size of the image is 1/4. Now in case of concave mirror, all the images are real except one case where the image gets magnified. As here the size of the image is 1/4 the size of the object, definitely what will happen, the image size I will be negative, because in real image the image is inverted. Okay, so I here it will be basically negative, and object height is always, as you know, positive. So something like this. Now this is equal to, then I is minus 1/4 X by object size X. Now if you just simply do calculations, X and X is cut out. Okay, this minus and minus and goes. So basically your V stands out to be V by minus 40. V by minus 40 is equals to 1/4. Then V, the solution is something like this. V is equals to minus 10, isn't it? The minus 40 is cross multiplied, goes up, then V is equals to minus 10. So the image distance is found out to be how much? The image distance is found out to be 10 centimeter, minus 10 centimeter. Why the minus sign is coming? Because the image is found in front of the mirror. So if we are considering how the position of the image, okay, the position of the image, it is basically in front of the mirror. So calculate the distance of the image from the mirror. The distance of the image from the mirror is 10 centimeter in front of the mirror. Okay, so the solution, so the answer will be something like this. So this is basically the first part of the solution. Okay, so mark it here as 1. Okay, I hope you have noted down these things. Then we are erasing it off. Okay, if you have not, please pause the video and note down these solutions. Okay, then we will be writing the answer something like this. Therefore image distance is equals to 10 centimeter, and in bracket you will write in front of mirror. The negative sign indicates that the image is in front of the mirror. Okay, so in front of mirror. Fine. Okay, now the second part of the solution. Second part, it says that you have to find out the focal length. So now it's easy. We know that there is a formula relating the focal length, image distance and object distance. What is the formula? It's 1 by f is equals to 1 by u plus 1 by u. This is the formula that relates the focal length, object distance and image distance. No derivation is required, just remember the formula, memorize the formula. 1 by f equals to 1 by u plus 1 by v. Okay. So if we consider this formula, then just simply put the values here. So 1 by u is 1 by minus 40 plus 1 by minus 10. You have to put the signs properly, otherwise it will be a problem. So if we just do the LCM, it turns out to be something like this. Then 1 by f, so we are continuing it from here. 1 by f equals to LCM is 40 and this will be minus 1 and this will be minus 4. So it's minus 5 by 40. Then f is turning out to be minus 40 by 5, means it's minus 8, isn't it? So focal length is 8 cm. As you know, for a concave mirror the focal length is always negative. So the focal length turns out to be negative from the calculation also. So the focal length becomes to be 8 cm. Okay. So therefore we write the solution something like this. Therefore the focal length is focal length. Now when you are writing the solution, you need not mention the negative sign. Focal length is 8 cm. As you know, for a concave mirror it is always negative. So focal length is 8 cm. So this is the solution. So I hope the numerical problem is clear. Okay. Okay. Let us consider another simple problem. It will be let us consider shorter problem, not a linear problem. Let us consider shorter problem. Okay. So okay. So this is from the exercise. Although I will be writing the question, I am just mentioning it. This is from the exercise. So I hope you have gotten to the solution. Okay. So we have to be a little bit quick as time is passing out. Okay. Now the second problem. What is the second problem? It says okay, question number 2. An object is placed 4 centimeter in front of a concave mirror. Okay. Then it says of a concave mirror of radius of curvature. So the radius of curvature has been mentioned. Radius of curvature 24 centimeter. Fine. Then it says find position of image. Means you have to find out the image distance. Find position of image. Also it has been asked, is image magnified? So you have to also find out whether it is magnified or not. Okay, so these are the two parts that we need to solve out. Okay, fine. Now let us quickly move on to the solution. So first of all, the first thing is you have to write down the given things. What are the given things here? Object is placed 4 cm in front of the concave mirror. So object distance. So object distance has been given. So object distance is given, denoted letter U is given as 4 cm, is always negative. So write the negative sign here. Okay, then it says radius of curvature. So radius of curvature is denoted with letter R. Radius of curvature is denoted by letter R. It's basically how much? 24 cm. So it's for concave mirror is negative. So it will be here negative sign given. So from this you can find out the focal length. A is equals to R by 2. So the focal length turns out to be 12 centimeter and it's negative. Okay. Now what else has been given? Nothing. We have to find out the position of the image. That means we have to find out the V. So first part of the solution. So let us consider the image distance. Let image distance be V. Okay. So I am just wrapping up the question. I will be doing the solution of the above part. Okay. So this is the first part of the solution. This is basically the first part. Then we are carrying it from here. Okay. Now, then we know we have the formula 1 by f is equals to 1 by u plus 1 by v. Mention, don't forget to put the proper signs. So 1 by f means 1 by minus 12, 1 by u means 1 by minus 4 plus 1 by v. So you can write it like this. Just let me separate it from this part. Okay, so this minus 1 by 12 equals to minus 1 by 4 plus 1 by v. If you do the solution, it will be coming out something to be like this. 1 by v is equal to minus 1 by 12 plus 1 by 4. Now the LCM turns out to be 12 minus 1. Here it's 3 plus 3. So it's 2 by 12 means 1 by 6. Therefore the v turns out to be 6 cm. Now it's positive. It's positive. Hence the image distance is basically it's positive. Okay. So positive means the image is formed behind the mirror. So we will be writing it like this. Therefore image distance is 6 cm is equals to 6 cm. Don't forget to mention behind the mirror. Okay. So it's a virtual image. Basically it's a virtual image. Basically it's a virtual image behind mirror. Okay. So it's a virtual image. Fine. Okay. So this is the solution. Okay, and is the image magnified? Yes. How can we find it out? Is the image magnified or not? Let us calculate the value of m. So m is, as you know, minus v by u. Okay. So m is, as you know, minus v by u. The second part, is the image magnified? Let us see. M is equals to minus v by u. So minus sign remains outside. V is 6 by u is 4. It's minus 4. So the minus sign cuts out. It's 6 by 4 means it's 3 by 2 means it's 1.5 positive. So definitely we know, as the value of magnitude of m is greater than 1, without considering the sign, value of m is greater than 1, it is magnified. So it's magnified. Hence it is magnified. Okay, so image is magnified. Fine. So I hope the solution is clear. Okay, so for today's class we will be ending here. We will be doing 2 or 3 more problems in the next class. Till then, please do study well. If you have any query, mention in the comment box. Till the next class, thank you. Goodbye.